Hey, grade 9. So today we're going to be working on portable power. Portable power means batteries. And how do we make them and how do we use them? So how did we start out with this? So this lovely person called Luigi Galvini noticed that when a frog touched two different metals, its muscles would twitch. He called this animal electricity. We now know that when you've got two metals that are placed in salt water or an acid, voltage can be generated. This is called the electrochemical cell. If you want to see what he was looking at, you can go back and look at this lovely YouTube video here so you can see what's going on. Okay, the electrochemical cell, though, is the study of chemical reactions used to produce electricity. It is a device that creates voltage using chemical reactions and has two different metals in a salt or acid solution called a voltaic cell. And it takes the chemical energy and turns it into electrical energy. So you also know that during this week you're going to be working on different energy changes. So make sure that you're kind of taking note of what energy changes are occurring. So our electrochemical cell has an electrolyte in it. So that is the liquid, the salt or the acid, and it conducts electricity. Electrolytes need to have an electrode. So the electrolyte, acid, base, salt, water, the electrodes are the metals. So the metals that you put into the electrolyte, you need to have a positive electrode and a negative electrode, both being conductors. And so for good electrode examples, you've got copper, zinc, lead, and silver. So how does all of this work? The electrolyte reacts with the positive electrode and loses electrons. The electrons travel from the positive to the negative end through the electrolyte, and the electrolyte reacts with the negative electrodes to gain electrons. Those electrons pass along the conductor wire to the light bulb. So it just continues and closes off the loop of our circuits and allows the electrons to move through those electrolytes. It's really important that you know the terms electrode, electrolyte, and then the difference between a cell and a battery. So eventually, all of these reactants, because it's a chemical reaction, all of the reactants will be used up, and the electrode and the electrolytes will no longer be able to cause the reaction to happen. This means that the battery is dead, and you need to be able to replace it. So what types of batteries do we have? We have wet cell batteries, and we have dry cell batteries. A wet cell battery uses a liquid as the electrode. It literally is wet. A dry cell battery, on the other hand, doesn't have a liquid in it. It's dry. It has a paste or a gel or ceramics. It can even have a solid in there as your electrolyte. So when you're looking here, this diagram over here of what your battery is going to be important, that you've got your positive, and you've all been telling me when we've been talking that you know the positive of the battery is the part that kind of sticks up a bit. Well, that's actually the electrode itself sticking up through the top of the battery. And so that is your positive electrode, which is then surrounded by the electrolyte paste. And then you've got your negative being on the outside of this container here and touching onto the bottom. So the electrons flow out the negative through your circuit into the positive, and then within the battery itself, they go from the positive to the negative. So a true battery means you have more than one cell inside of it. So there are very, very few single cells that can produce more than 2 volts, which you'll see with our fruit batteries this week. So to get a 9-volt battery, you need to have 6 1.5 volts inside. So some of you have even told me that you've looked inside of batteries before. I do not recommend you opening up batteries at home on your own because battery acid is not good for you. That's the electrolyte. It's not good for you to have around, but there are the insides. So instead of you doing it yourself, let's look at one here. So inside of the C batteries, you might have like a whole bunch of single or 1.5 volt cells together added up in here. The 9 volts has like little batteries, like 6 of them going in a circle that way. So it's really kind of neat. And when they're added in series, you add the voltages together. So you'd have like 1.5, 1.5, 1.5, 1.5, 1.5, 1.5, which gives you the 9 volts that you'd have for that battery. Okay, so we have primary cells. Primary cells, there's so many little terms in here, but primary cells are one use only. You use it, you use up all the chemical reaction inside. When it's used up, you're done. You can't use them anymore. They're basically thrown out. So when you look at these batteries, and you sometimes look at the things that you have that take batteries, I always personally wondered why, like, what's the difference between a D battery and a AA battery? There's actually nothing at all different between them. They're made exactly the same. It's just your D battery has more of the chemical inside, so the reaction can last longer. It's a longer lasting 1.5 volt battery. AA, also 1.5 volts, has less of the chemical in there, so it will be used up much quicker. Secondary cells are meant for many uses. So these are our rechargeable batteries. And what happens is they've got the same chemical reaction inside, well, slightly different. And then they actually use electricity when you put them into the charger to move that chemical reaction back or reverse it. So they're going to reverse that chemical reaction and get their chemical energy back. So you start out with all batteries with your chemical energy and you turn it into electrical energy. But when you are recharging your battery, you take the electrical energy and turn it back into the chemical potential energy that you had before. So when you look at this, and I realize that my face is in the way, here, let me slide my way up over here. When you look at the comparison between buying primary versus secondary cells, you look at the first price and you're like, oh, of course I'm going to buy these single cell batteries, because on primary batteries, why wouldn't I? It's $6.99 compared to $30. Oh my goodness. But if you had to buy 400 batteries over the course of the lifetime of whatever you need your battery for, this is going to end up costing you $700. Whereas with these secondary cells, that $30 up front is all you'd ever need to be able to get the equivalent of your 400 batteries. All right, let me move myself back into the corner. So now here's some just different common cells and batteries that we use. So we've got our zinc carbon batteries, our alkali batteries, our lead batteries, and our nickel metal hydrides. So just take a look at this. Make sure you look at the pros and the cons. I realize my face is in the way here, so I'm going to let you read this one on your own. And that will get us through the key points of topic 5.